Hey guys, it's me, and this is your second video. I wanted to start you out with a quote. Men love to wonder, and that's the seed of science. And I want you to think about that as we go through this lesson. This is a review of thinking like a scientist. So, what kinds of skills or things does a scientist need in order to be successful? Well, the first thing is that a scientist needs to make some observations. You've been presented with a problem, and now you need to make some observations. Now, what are observations? They're basically scientific pieces of scientific data that's used and gathered by making your five senses: sight, smell, touch, taste, hearing. Now, sometimes I can physically measure those and I can give them a number. Like you see my house. That right there, I have one lamp on that table. Well, one lamp is going to be a quantitative observation. I use a number. I can physically count. But I could say that the chair that I'm sitting in is red. And that description is qualitative. It's using adjectives and adverbs. Now take a look at this picture. This picture has lots of different things. This is what was in a garden in Virginia. And this garden has things that are pink, green, black. I could count numbers. Any of those kinds of observations are going to be qualitative and quantitative observations. Now, I've got a question for you. Miss Cummings is 5 feet tall. Is that quantitative or is that qualitative? And I'll give you just a minute to take care of that. Now, 5 feet tall, I can physically measure myself. That's a number. So it's considered quantitative. That is a quantitative observation. Now, let's try another one. Miss Cummings' classroom is cold. If you said qualitative, you are correct. That is something that I can feel. Obviously, I'm using my sense of touch, but I can't physically measure it unless I have a certain kind of tool. So things like cold, hot, rough, those are all going to be examples of qualitative observations. So let me go back to my picture. There are pink, fluffy objects. There is black looking sticks. There are gray substances. Those would all be examples of observations. Now, what happens if I make my observations and it's based on something that I have no idea what it is? Well, that's when a scientist is going to use something called an inference. They're going to make inferences. And you guys are going to be making inferences all week long. Inferences, we take our observations and we make them into possible explanations. Well, how do I do that, Miss Cummings? Well, I take the observations and then I add my prior knowledge of that particular subject area and I put it together, and it's a statement, but my statement may be different than someone else's statement based on my prior knowledge. So let's go back to my picture. I see here that there are pink, fluffy objects. Now, I know from prior knowledge that sometimes flowers can be pink. I know that flowers grow out of the ground. And I know sometimes they have black or colored pieces in the middle, and they can look fluffy. So I'm going to say that the pink, fluffy objects are flowers. That is my inference. I've used my observations. They're pink, they're fluffy. I've used my prior knowledge of flowers, and I can put that together and show that that is an inference. Now, the last piece is a measurement piece. Measurements are important. They're important tools for scientists. We use the International Standard for Units. So if I'm in the United States and I'm sending my information to a scientist in Europe, there's no confusion. They don't have to worry about converting. We don't have to worry about any sort of confusion. And so measurements are going to be part of your observations and inferences. And that's a wrap